All right, let's talk about a real rebel in the world of physics, a man named David Bohm. He was, without a doubt, one of the most important and definitely one of the most unorthodox theoretical physicists of the 20th century. This is a guy who looked at the very foundations of reality and said, nope, I think you've got it all wrong. So, check out this quote from another giant of physics, John Stuart Bell. But in 1952, I saw the impossible done. Wow. What a statement, right? So, what was this impossible thing that Bohm pulled off? Well, he came up with a completely different way to look at the quantum world, an idea that almost everyone else had said was, well, impossible. To really get why this was such a bombshell, we need to understand the puzzle he was wrestling with. You see, in the middle of the 20th century, physics had this weird but incredibly successful theory about how reality worked at the smallest scales. The only problem, it described a universe that was fundamentally random, fuzzy, and uncertain. And David Bohm just refused to buy it.
I mean, this is the question, isn't it? What's really going on down there? Is the universe, at its very core, just a cosmic roll of the dice? Or is there something else? A hidden, deeper order ticking away beneath it all? One that we just haven't been able to see yet? This was the battleground, and it's where Bohm drew his line in the sand.
Okay, so here are the two sides of the coin. On one side, you've got the heavyweight champion, the Copenhagen interpretation. This was the mainstream view. It basically says things are just blurry. A particle doesn't have a specific location until we measure it. The act of looking, in a way, creates the outcome. Now, on the other side, you've got Bohm, and he wasn't alone. Albert Einstein was in this camp too. They just couldn't stomach that idea. In fact, after Bohm wrote a textbook on quantum mechanics, Einstein himself called him up, and that kicked off months of conversations. They both felt that, yeah, the theory made great predictions, but it just couldn't be the whole story. Bohm's goal was to bring back an objective, deterministic reality to physics. But to really get where these radical ideas came from, you have to look at Bohm's life. His story is, well, it's pretty wild. And his biggest breakthroughs didn't happen in some fancy university lab. They happened while he was in exile. Just look at this timeline. In 1943, the great Robert Oppenheimer wants him for the Manhattan Project. But nope, he's denied clearance because of his politics. Later, during the McCarthy witch hunts, he refuses to testify against his colleagues. He gets arrested, and even though he's acquitted, Princeton University fires him. Suddenly, he's unemployable in the entire United States. He's forced to leave, and he ends up in Brazil. And it's from there, in total intellectual isolation, that he publishes his game-changing papers in 1952. Talk about working outside the system. So what was in these papers? What are these hidden variables? Well, Bohm's idea was that quantum physics only looks random because we're missing part of the picture. He argued that particles, electrons, photons, all of them, always have a real, definite position, and they're guided by a real wave, something called a pilot wave. But here's the truly mind-bending part. For it to work, the theory had to be non-local. This means that particles can be connected, linked, no matter how far apart they are. You could do something to a particle here on Earth, and its partner, even on the other side of the galaxy, would react instantly. It's this non-locality, this spooky action at a distance, that actually made his theory compatible with Bell's later work. And this is where things get really deep. Because for Bohm, this wasn't just about physics equations anymore. His work led him to this incredible philosophical vision of the entire universe as a single, flowing, undivided whole. He came up with these two amazing concepts, the implicate and the explicate order. Think of it this way. The explicate order is the world we see around us. Separate chairs, tables, people. It's what's been unfolded for us to see. But Bohm said that's just the surface level. Underneath it all is the implicate or enfolded order. And in that deeper reality, everything, and I mean everything, is connected. It's all one unbroken, seamless whole. Now, I know, enfolded reality sounds pretty abstract, right? It's a tough idea to wrap your head around. But Bohm came up with a brilliant analogy to help explain it. The hologram. You know how a hologram works, right? The entire three-dimensional image is encoded onto every single part of the photographic film.
If you take that film and smash it into tiny pieces and then shine a laser through just one tiny shard, you don't get a little piece of the image. You get the whole thing back. It might be a bit fuzzy, but the whole picture is there. And that's what Bohm was getting at. He suggested the universe is like that the total reality is enfolded within every region of space. The separate world we see is just the unfolding, the projection from that deeper whole.
But of course, a hologram is static. It's a frozen picture. And reality is anything but static. It's a constant flow. So Bohm called this universal dynamic process the Holomovement.
And this quote just nails it. The Holomovement is the unbroken, undivided totality of, well, everything. All the things we see, particles, stars, even ourselves, are just temporary patterns, like little whirlpools in a flowing river, constantly forming out of this deeper reality and dissolving back into it. So here's where Bohm takes this massive leap. He saw this idea of fragmentation in physics, and he thought, wait a minute, this isn't just about atoms, this is about us. He believed that the fragmented way we think is the root cause of most of the world's problems.
I mean, think about how we chop up the world. My country versus your country. My group versus your group. Me versus you. Bohm said this fragmentary thinking is a dangerous illusion. It's what leads to conflict and chaos. But he didn't just point out the problem, he actually proposed a solution, a practical one.
He developed something called Bohm dialogue. And it's a totally different kind of conversation. First, you suspend your assumptions. You don't try to defend your opinions, you just become aware of them and hold them out. Second, you listen to the group as a whole. You're trying to feel the flow of meaning in the room. And if you do that, you get to step 3, creating a shared pool of meaning. A new collective understanding emerges, one that no single person could have come up with on their own.
This just flips the whole idea of conversation on its head. In a debate, someone has to lose. In a dialogue, as Bohm saw it, everybody wins because you're not trying to convince each other. You're co-creating something new.
So after all that, what do people think of Bohm's ideas today? Well, his legacy has had a fascinating and pretty dramatic shift over the years.
Initially, the physics world was pretty hostile. The great Wolfgang Pauli dismissed his theory as artificial metaphysics, basically philosophical fluff. But then, look at the change. Decades later, John Bell, the guy from our first quote, became one of its biggest champions. Bell argued that Bohm's work proved a crucial point. All that weirdness in quantum mechanics, the randomness and subjectivity, wasn't a fact of nature. It was a choice the physicists had made.
And here is the real kicker. That number. 0. That's how many experiments can tell the difference between Bohm's theory and the standard one. They make the exact same predictions. Think about that for a second. We have 2 completely different stories about reality. One is random and created by observation. The other is perfectly ordered and deeply interconnected. And experimentally, we can't tell which one is right.
And his legacy goes way beyond physics. You can see here, this is from an academic journal in theology, of all places. His ideas about the Holomovement and the Implicate order have inspired thinkers in philosophy, in consciousness studies, all over the map, really. People are still captivated by this vision of a deeply interconnected reality.
When you boil it down, David Bohm's life and work were a rebellion against fragmentation in physics, in our minds, and in our society. And he leaves all of us with a profound challenge. Bohm challenged us to see the world not as a collection of separate little bits, but as a single, undivided whole. So I'll leave you with this to think about. In our world today, which feels more fragmented and divided than ever, what can we learn from one man's vision of an undivided universe? Thanks for joining me.